For decades, astronomers have believed that our solar system is home to no less than 8 planets. While Pluto was once considered the 9th planet, studies over the years have proven that it is too small to be classified as such. However, NASA has now found new evidence which may prove the existence of a 9th planet hidden somewhere beyond Pluto. Let's take a closer look. Astronomers know very little about the far outer solar system, beyond Neptune, Pluto, and the far-flung Kuiper Belt. For the past several years, some scientists have observed certain gravitational anomalies in this mysterious region and have theorized that there must be an undiscovered world, dubbed Planet 9, lurking at the outer edges of our galactic backyard. If true, this planet would be unlike any other in the solar system. At 10 times the size of Earth, it takes some 10,000 to 20,000 years to orbit the Sun. For comparison, it takes Neptune only 165 years to make the same trip. But there's an alternative explanation to these anomalies. Some astronomers believe a whole belt of icy bodies, some potentially as large as Earth, could explain this. 2 years from now, the fate of Planet 9, this new space belt, and other alternative explanations will be tested when the Vera C. Rubin Observatory opens for first light. Perched atop a mountain in central Chile, the observatory will begin its legacy survey of space and time in 2024. Once this next-generation telescope gets to work, it could discover thousands of objects we never knew existed and completely alter everything we know about our solar system. In 2016, Caltech astronomers Mike Brown and Konstantin Batygin hypothesized that some of the head-scratching phenomena occurring in the outer solar system, especially the strange and extreme orbits of dwarf planets and other icy objects, all pointing toward the same section of space, could be explained by the existence of a 9th planet. This hypothesized world would have to be about the size of Neptune, and its closest approach to the Sun, or perihelion, would be a staggering 300 astronomical units, or about 27.9 billion miles. For comparison, Pluto's perihelion is only 29.6 AU. If Planet 9 is real, it wouldn't be the first planet discovered from the force it exerts on other objects. In 1846, scientists knew another world must be out there due to the anomalies found in Uranus's orbit. After some elegantly complicated calculations by French astronomer Urbain Le Verrier, Neptune was discovered soon after. Fast forward to the 21st century, and some astronomers think history will repeat itself. If Planet 9 is real, it would be in such an odd orbit and so far out in the outer solar system that it would challenge our ideas of planet formation and dynamics. This is why astronomers aren't searching for just one planet. They are looking for an entire belt of celestial objects. Like Planet 9, this proposed belt, called the ZM belt, would exist far beyond the Kuiper Belt, with some of its closest bodies being more than twice as far from the Sun as Pluto at perihelion. Unlike the Kuiper Belt, this ZM belt tilts off the orbital plane, exhibits orbital clustering, and contains upwards of 10 Earth masses of material, similar to the prediction of Planet 9's mass. That's a lot of unknown debris floating out there, considering the Kuiper Belt contains less mass than even one Earth. Running simulations focused on the gravitational interaction between the bodies of this hypothetical belt, astronomers discovered that their theory explained why some bodies all uniformly orbit around the Sun in such a strange way. They believe that some already discovered dwarf planets like Sedna and 2012 VP-113, nicknamed Biden, are members of this ZM belt. Sedna, for example, has a perihelion of 76 AU and could represent the inner edge of this hypothetical belt. If true, then untold thousands of similar objects are still waiting to be discovered beyond it. Assuming this planet-like object does exist out there, Planet 9's mass would most likely be a magnitude greater than Earth's, with a girth approaching the range of one of our ice giants. A likely scenario explaining the body's far-flung position puts its origin somewhere between the orbits of Jupiter to Neptune, with a birth much like any of the other gas planets in our solar system. Before it could gorge itself, Planet 9 would have received a kick from the gravity well of one of the two gas giants and found itself out among the icy wastes. Despite its large, slow orbit, enough time should have passed since the dawn of the solar system for it to have cleared its orbit of frozen chunks of dust and rock, earning this stunted gas ball an official planetary title. Alternatively, though vanishingly less likely, Planet 9 could be an adopted child snatched away from another passing star long, long ago. Astronomers first began searching for Planet 9 in 2016 when they noticed that 6 rocky objects beyond the orbit of Neptune clustered strangely, with the most distant points in their orbits located much farther from the Sun than the nearest points of their orbits. The team calculated that the gravitational pull of an unseen planet measuring 5 to 10 times the size of Earth could explain the eccentricity in those rocks' orbits. Half a decade later, many teams have tried and failed to detect that theoretical world. The biggest hurdle in the hunt for Planet 9 is the sheer distance involved. While Pluto orbits between 30 and 50 AU from the Sun, the authors of the 2016 study estimated that Planet 9 could be anywhere between 400 and 800 AU away. So far away that sunlight may not reach the planet at all. That means there's little hope of ever detecting the cold, dark Planet 9 with standard visible light telescopes. Instead, astronomers turn to the likes of the ACT telescope, which can search the cosmos in millimeter wavelengths, a short form of radio waves that come close to infrared radiation. Millimeter telescopes are often used to peer into the dim, freezing gas clouds where new stars form because such clouds don't absorb millimeter light, according to the International Research Institute for Radio Astronomy. While this survey failed to turn up any compelling evidence of Planet 9, new millimeter telescope facilities, such as the Simons Observatory that's currently under construction in Chile's Atacama Desert, will continue the search with even more sensitive telescopes, allowing researchers to narrow down even further where our long-lost neighbor might be hiding. Some theorists have put forward a radical hypothesis that states that Planet 9 may not be a planet at all. Rather, it is a small black hole that might be detectable from the theoretical radiation emitted from its edge, so-called Hawking radiation. Small black holes are very interesting to astronomers. All black holes we know of in the universe come from the deaths of massive stars. And because only the most massive stars are big enough to form a black hole, they can only leave behind black holes with a minimum mass of around 5 times that of the Sun. But black holes smaller than that could have formed in the extreme conditions of the early universe. These primordial black holes could flood the cosmos, but cosmological observations have ruled out most models of primordial black hole formation, with a few narrow exceptions, like planet-sized black holes. So, if scientists can confirm that a small black hole is orbiting the Sun, it could provide an intriguing look at one of the greatest mysteries of modern cosmology. In the 1970s, famed physicist Stephen Hawking theorized that black holes aren't exactly 100% black. Due to a complex interaction between gravity and quantum forces at the event horizon, or boundary of a black hole, he proposed black holes can indeed feebly emit radiation, slowly shrinking in the process. But a small nearby black hole might be more accessible. Previous research had already shown that its Hawking radiation would be too weak to be seen from Earth, but new research investigated if a flyby mission would have a better chance of spotting the Hawking radiation from such a black hole. The results state that even when using a fleet of lightweight, fast spacecraft to scour the outer system, we are very unlikely to spot Planet 9 through its Hawking radiation. The radiation is just too weak, and because we don't know the location of the black hole, we can't guarantee we can get close enough in a chance flyby. But not all hope is lost. If scientists can more conclusively pin down the location of the hypothetical Planet 9 using other observations, and it turns out to be a black hole, then a targeted mission can fly close to its event horizon and possibly orbit it. There, we would have direct observational access to one of the most extreme gravitational environments in the universe. No wonder astronomers are excited by the prospect of a black hole in our solar backyard. A mission there would be incredibly expensive and time-consuming. But we have experience with these kinds of long-distance missions in the form of New Horizons, the NASA probe that is currently sailing through the Kuiper Belt. It's within our technological reach to design and fly a longer-term version of New Horizons to visit a nearby black hole. Black holes are perhaps the most mysterious objects in the cosmos, and we do not fully understand them. In particular, Hawking radiation itself would teach us about the relationship between gravity and quantum mechanics at small scales. If Planet 9 is a black hole, within a few years, we could launch a mission to observe it in detail and hopefully answer some long-burning questions in physics. New reports from NASA state that if the elusive planet does exist, astronomers may finally have a decent chance of spotting it. NASA has recently announced that a planet about 10 times more massive than Earth likely lurks in the distant outer solar system, orbiting perhaps 600 times farther from the Sun than Earth does on average. The the evidence for the existence of this Planet 9 is indirect at the moment. Computer models suggest a big, undiscovered world has shaped the strange orbits of multiple objects in the Kuiper Belt, the ring of icy bodies beyond Neptune. But direct evidence could come relatively soon in the form of telescope observations. The data collected is bright enough that on its closest approach to the Sun, the planet may even be visible with some backyard telescopes. This means that Planet 9 is not too close to the Sun at the moment. However, there is a chance that powerful ground-based telescopes may still be able to detect it. The 27-foot-wide Subaru telescope in Hawaii is the go-to observatory for the search because Planet 9 is predicted to be visible in the northern hemisphere sky. Astronomers state that it is still tough to know just how detectable the planet would be, considering the uncertainty surrounding the putative world size, orbit, and composition, as these characteristics affect the brightness of the planet. Scientists believe they have already covered some parts of the planet's possible orbit using the Subaru telescope, as part of a larger, years-long survey for more objects, such as 2012 VP-113. The researchers will likely use Subaru to narrow in on more promising possible locations. But the hunt for smaller bodies, such as 2012 VP-113, will continue as well. The hunt for Planet 9 will also probably send astronomers back to their archives. The undiscovered world may have already been photographed by powerful telescopes, but researchers didn't spot it. If you like this video, you may also enjoy this one, which talks about NASA's latest discovery of 2 super-Earths that could sustain life. Do you think Planet 9 exists? Please share your thoughts in the comments section below.